Hello guys, welcome to my live, and today we want to practice some scenario, and here we have a case study of my of my one of my module. So here we have few routers. Actually, I should separate them to few area. We have one area here and we have another area here, and guys, let's live in on TikTok, and I'm waiting for TikTok guys. Come on guys. Well, here we have another idea area. The topology is about the international travel agency. And here is AS 100. We have a IPSA here. Let's set up everything. Windows capture. I want to okay, now we are live all in a TikTok. Perfect. Come on guys. And here the name of here is nothing. Send shows 3 and send shows 1. Okay, here I should write everything because we need all of them during we configure the router. Area 2 and SSA. Easy IP redistribution RIP. And here is London, area 1, totally okay. The name of here is AS 200. Nice. Sorry guys. Let's continue our topology. Okay, here is Cape Town. Here, between here we have a BGP T1, T3, T3. Okay, we have a lot of details here. Internet. And here we have a server, London, everything alright? Yes, I think everything is right. And here is let's focus what happened here. Here we have a web server, oh, okay, and this is so interesting because we need to find what is the problem of this topology and what is the advantages of this topology. Also, we need to make a good report, and thinking about when we want to report to our manager, how can we write a good report. So we need to find the problem, we need to find advantages and everything, and configure one by one the routers with a different protocol, different rules. Then we're thinking about how can we improve this topology. Now the our international travel agency is like this, and we need to understand first. We need to understand how it works. Here is London, and here is another city. Okay. First of all, we need to write our name, our everything. So I open a document, and I write everything. For example, I write my name, I write my module, for example, word count, source, assignment, brief, and everything. Yeah, we goes to executive summary. We need to understand, here we need to understand what was done and how can we write it. For example, let's find something good, because this is my first time I see this topology. Okay, we design, configure, and validate multi-area OSPF here and here and here. We have a three different area, and we have a BGP connection to the internet, primary T3 here, as you can see. And what we have, and we addressing OSPF for scalability. OSPF area 1 core is San Jose, area 1 is London, and area 2 is Cape Town as NSSA. Area 3 as a RIP area with redistribution into OSPF and default route injection. BGP AS200 internal, 2 ISP neighbor implemented, and router policies ensure all outbounded inbounded prefer T3 and failure to T1. Okay, this is nice. Also, I think we need to verification, test evidence, like a show command, simulate output, IP addressing table, route summaries, logs, and ethical design. Yes. And we need to go this part. This part is aim and objective. Our objective is implement a scalable OSPF multi-area design consist with the diagram in the brief. Configure area 1 is here. Where is area 1? Here in London. Then we need to configure area 1, area 2 as an NSSA and summarize route into the area 0. Set up RIP area and redistribute RIP into OSPF. So it is so important here. We need understand all of this. Ensure RIP area use a default route to reach to the REST network and internet. Okay guys, we have a three different protocol in this topology. First one is OSPF, two is BGP and RIP. Yes, first we need to understand all this protocol, because if we don't understand how they works, how they follow the rules specifically for itself, we can't understand this topology, and we just filled all commands and we don't know what happened at behind. The another objective is implement BGP primary T3 backup T1, prefer T3 for inbound outbound traffic, provide an IP address using VLSM, and enable summarize for scalability. Okay, VLSM is another thing we need to study about it. I prefer to study it again, all of them, because we need to understand, as I said. Guys, if you have a question, just ask me. Don't be shy. Just ask me. Yes. And guys, we need to provide an IP, provide configuration output, test and verification step, and analyze. Produce group meeting minutes logbook entire for week 4, 7, and 10. The narrative core Sanjos routers run OSPF area 0. You can see it. Yes. Could you find area 0? Here. Here, guys. Look at my mouse. And connected ABRS to the 3 other areas. London is area 1, Cape Town is area 2, is NSSA to allow limit external redistribution while preventing full AS external router into the area. The RIP area, could you find RIP area? I can't see it, but you can see it here. The RIP area is connected to an ABR that redistribute RIP into OSPF. RIP area uses default route to reach the rest of the network internet. San Jose's multi multi and to IPS 1 and primary tree and backup T1 link. All edge routing use BGP AS200. Now guys, we need to understand how to IP addressing and summarize plan. Okay, we need to design. The brief allocated one class A license. We use provide 10.0.0.0/8 to internal addressing. To make summarization easy, we assign each area a /16 block. To each area can contain many 24 subnets, /24 subnets. This permits summarization at ABRS as /16s, reducing routing table size in the core. Area allocations is core area 0 is here. The IP is 10.0.0.0/16, this network. The London area 1 is 10.1.0.0/16. Area 2 is 10.2.0.0/16, and area 3 is here. RIP area is 10.3.0.0/16. We have a loopback router's ID use 10.20.255 per device. For example, inside area 1, this is one sample. London LAN 1 is 10.11.0 and London LAN 2 is 10.120/24 up to 10.130/24 for 30 networks per area as required. Guys, is there any question? Okay, nothing. And okay, this is our um, topology, and I want to you think about it, how we can improve it. So next slide, we study OSPF, BGP, and RIP and VLSM. To understand all of them, then we go to configure it practically. After that, we summarize plan, configure output and verification, troubleshooting, analyze and testing, implement issues, limitation, and 2 suggestions for improved design. Okay guys, see you later. Bye.